question?
I don't know. What does sandpaper use to grind out rough edges?
Not.
Something like that.
Okay, so what was the question?
What does sandpaper do?
Okay, so what does sandpaper do to make the surfaces smooth? What did you guys put for that?
Grinds out the rough.
Okay, so it takes off the rough parts. So what the job? What the job of sandpaper is to make sure that you have, guys, is it puts finer and finer scratches into the actual surface. So the job of sandpaper, guys, enough. Is to, like I said, put finer and finer scratches into the object, whatever we're sanding. Okay. Can you guys shut the lights off? So what you're supposed to watch is the sanding video for today. Okay. And what that talks about is we have four different grits. So we have we have 80, 120, 180, and then 220. So, did anyone watch this? That's what I figured. Okay. So the thing that you guys need to make sure is that you'll be using the palm sander for the 80, 120, and 180, and then you'll hand sand it with the 220. Okay. So the orbital sander, what that does is it basically has this plate down here that, like the name says, it orbits around in a circle. One of the downsides of that is that you actually have, it leaves some C's or some actual marks. So if you remember back to that movie with Surf's Up, you always go with the grain, okay? So when you're sanding, when you're actually moving it back and forth, move the palm sander back and forth with the grain. And what it actually ends up doing is if you end up moving up to the next grit too fast, you can get these marks on there, these little C marks. If you guys ever go to places, I think like, where is this? I think Applebee's has it. Like if you're actually looking at the table, Texas Roadhouse, they have a darker stain on their tables, and it's mass produced. And you can definitely, if you look down through the poly, you can actually see this. Okay, so that's when if you don't take your time sanding, you can actually see it, the marks on the table. So what you want to do is, like I said, before you move up to the next step or the next grit, you want to make sure that you have all the marks from the previous sander out. Okay, so the first thing that you'll be doing with the 80 is, I don't know if you guys can see this, but especially like right here, you have these marks. What are those marks from? The surfacer, right? Or the planer. So these are actual marks from the blades coming down and notching that out. Okay, so that's what you want to make sure you sand that off with the 80. So the sandpaper itself, you can see here, it's more aggressive, so you want to actually take off all those marks. So you want, in order to get a nice smooth surface. So you're putting finer and finer scratches in that. Once you have all those marks done, like here you can see those, you want to just start moving up to the next one. So that was 80 would basically, it's the most aggressive, it gets rid of all these machine marks. Then you move up to 120, go from there. And what you're doing is you're getting rid of all those little C marks that you have from left by the 80. Now, a common mistake is people actually, they don't want to spend time sanding, so they'll actually just push down on it harder. And they figure, well, they'll notice that the harder I push, what's gonna end up happening is that it takes out those marks faster. But what you're also doing is, yeah, you're taking out these machine marks, but you're putting those C's from the actual sandpaper, you're pressing those down into the material, okay? So you're actually making large, deeper scratches in that. So then in order to take those out, you have to spend a lot of time, or longer time sanding it with the next grade up. So as you move up, you should be spending, basically you're going to spend most of your time on 80, a little bit less time on 120, and then 220, really you should be able to get the whole thing done in like 5 minutes of hand sanding, okay? So yeah, it takes a lot in the beginning, but if you don't take your time, you're just going to spend more time once you get going on to the 220. With the orbital sander, I don't know if you guys can really see, not really in this one, but you kind of see these marks here. So those are a series of those like C marks in a line, and when you're using it, this person was going back and forth, okay, with the 80 grit. So it's not necessarily that bad. Like with the 80 grit, you can kind of go whatever way you want, but once you start bumping up in grits, what you want to do is start going with the grain and everything, okay? A better picture is here, as you can actually see, so all these swirl marks here, all that, what you want to do is make sure that you have that taken out, because like I said, sanding, what it does is it puts finer and finer scratches in the sandpaper, or in the actual object. So sandpaper is only meant to make something smooth. It's not there to remove material. If you end up, say this was left on the 80 and you jump up to 120 and then up to 220 too quickly, so you didn't take it off with the 120, what you're going to do is they're still going to be there, because you guys all know that grit, right? So what's more aggressive, 180 or 220? 80, right? So 80 has the bigger grits on there, it's more aggressive, and it's going to leave deeper scratches. So if you're trying to get it out with 220 by hand, okay, you're going to be sitting there a lot longer than just the needed amount of time, or the suggested amount of time for sanding. You're going to have to sand all that stuff off, and you're going to go down deeper to get those scratches out. Let's see what that is. Glass done again. A 10? Or how did it start at? What? 40. Okay. So what I want you guys to do is take out a piece of paper. What we're going to do is go into the CAD lab, but by the time we get over there and situated into do's and don'ts, we'll just go through it as a class. So grab out a piece of paper for your do's and don'ts.
See what we need? And Alex,
Guys, we're going to be working in here though, just so you know.
How many?
We'll just try and go for 10.
All of them. Off the sheet.
Yes, you can read those. Okay, we'll get started. What we have is, you guys want to see what Tristan wants? Doing. Alright, anyways, I just leave it up there. Thanks. So here we have our belt and disc sander. So what I want to make sure you guys know is on your design, guys, quiet, is your design. This is the machine that you're going to use for the outside curves. Okay, so anything that has the outside of a curve, you're going to use the belt and disc sander. Okay, because it's a straight surface working on the outside of a curve, so you're going to get a better result. So when you use that outside of curves, you're going to be using the disc part. The belt sander is just for smoothing out long, flat surfaces. So if you had a design pattern, or we won't really be using the disc sand or the belt sander too much. So when you turn these on, both of them operate off of one motor. So correct. So you can see that both of them end up turning on at the same time. So necessarily this isn't what you'd be using it for. You're not going to be dealing with it for end grain. Okay, this is just a piece of board that I grabbed as an example. And notice how I was working on the left side of the disc. Why would I work on the left side?
So it doesn't pick it up.
Yeah, because it spins in a counterclockwise direction. Okay, so if I worked on this side, what have the tendency is you'd actually want to lift the board up. Also, if I was holding it against the table, so when you're sanding on these machines, basically the belt sander is kind of the one exception. But when you're sanding, you always want to have it tight against the table. Okay, so you're never going to be freehand sanding, and you always want to work on the left-hand side of the disc. Okay. And then if you guys had ever have a chance to work on the belt sander, always stand on this side, just because you have, if you're standing here, what you have is a potential for actual, if you have loose clothing or anything like that, you're just working really close in this area right here. And then moving it back and forth. So using the whole width of that, why would I do that?
To preserve the belt and also to keep from friction.
Yeah, so basically you're making use of the whole belt, just like the blades on our planer or our joiner. You want to use the whole thing, so if we all use the one section, that one section would end up getting duller quicker. Okay, so it just keeps the life of the blade or the belt longer, and then like Josh said, it doesn't clog up those pores. So you have a chance for the pores to actually clean out. And with the pine, you don't want to do a lot of sanding. Like I said, yeah, pine is soft and it's easy to work with. That's why we're doing it in woods, or using it for this project. But it also has a tendency to clog the sandpaper, so the actual pores itself. So you want to kind of give it a chance to kind of clean out. So again, the main point when you're sanding is sanding only is meant to make something smooth, not to actually take off material. Like a lot of people say, well, it's just a little bit too short. Should I sand this off? No, because with sanding, you notice it's all by hand, right? I have this guide here, if I wanted this at a 45, yeah, I could get it close, but I'm not going to get as good of a result as I would with a saw. So if you have to take anything off more than, say, like an 1/8 inch, somewhere between an 1/8 and a 1/16 of an inch, use the saw. So sanding is just to make things smooth. It's not for actually taking off material. All right, so that's the outside, using for the outside. Then what we have is the spindle sander. Okay, so the spindle sander is for the inside of curves. So just as a quick example, this helps. So like here, on the outside of these curves, I would be using the disc sander, trying to get as much as I could. And then here, what I would use would actually be the spindle sander. So the inside curve, you want to use the spindle sander. So basically this part right here would be done on the spindle sander. Outside part would be done here on the disc sander. So that's helpful to get the majority of the work done. There are going to be spots where you do have to do some hand sanding on your design, but try and do the majority of it with the machine, right? Why use the machine when you can use the majority of it? Or why do it by hand when you can use the machine? The big thing with the spindle sander is same thing, making sure that you have, I don't know what I'm doing here. Have the right side diameter, so see how Ooh, I showed that nice, beautiful. Hold on a second, I'll just play this, watch. It's like I dare teach. Okay, well, no, you got it. Yep, bye. Okay, so what I was doing there at the beginning of the video was checking out the largest diameter. So if I had, let's see, an example of this one, this box up front here. If this was my design pattern that I wanted to use here, so I have a large arc, would I want to use a smaller diameter spindle or a larger diameter? Larger, why?
Because then you have to, like, you have the mesh also.
Yeah, so I can cover more surface area. Also, if I have a smaller one, it's basically, you'll find that it actually will want to make like indents in there. And if it's a larger one, it's more fitted to the needed or the required arch or radius that you're looking for. So you get a better result. So what you want to make, the main point here is match the needed, or match the two diameters up with one another. Also, when you guys are adjusting this nut up top, it's a self-tightening nut. So a lot of people want to think that, oh, I need to crank on it. Well, it's self-tightened. So in case this ever stops rotating, this is spinning, and what it does is actually it tightens it up. So if it was regularly, or if it was threaded the way most bolts or nuts are, what would end up happening is it actually would loosen itself. But since the threads are reversed, it actually tightens itself. So same thing like on the arbor blade of the table saw, the nut is the threads are reversed, so that in case anything were to bind or pinch on this blade while the motor is still running, it tightens it down. So the main point is here, when you guys adjust this, it just needs to be finger tight. Okay, you don't need to sit on and crank on there and reef on it, because then what ends up happening is we have to end up getting pliers because other people have stripped it out from before. If you notice here, you have your guards. Just make sure that you have the appropriate size fit down underneath. And again, use the table. Don't be freehanding. All right, have those turned in for Monday.
Back on the walk.